Okay, today's lecture is about some of the results of the beta and a gamma function, or some results are related to the application of a relationship between the beta and a gamma function. Our first question of today's lecture is evaluate integral 0 to infinity x raised to the power m minus 1 divided by m minus 1 raised to the power x dx. So what you have to do, you have to suppose you have to take that, let us suppose that integral is equal to I, that is your equation number one. And again, we are going to solve that integration with the help of a substitution, and that substitution is in a form of what? That is in a form of that we have to take m minus 1 raised to the power x like e raised to the power y, because if you look over here, so here we have a limit of a in limit of integration in a form of a 0 to infinity, so that is in a form of these are also the limit of a gamma function, so we will relate that integration with the gamma function. So for this we will take that m minus 1 raised to the power x is equal to e raised to the power y. So if you take log on both sides, so we will get x log of m minus 1 is equal to y, and if you want to find the value of x, so shift that log m minus 1 towards the right hand side, and now find the differentiation of that function. So that will be dx is equal to dy divided by log of m minus 1. So if you change the one variable into another variable, so you must have to change the limit of integration, and that if x is equal to 0, so y is equal to 0, and if x is equal to infinity, so y is equal to infinity. From here you can easily look over here that if x is equal to 0, so y is equal to 0. If x is equal to infinity, so y will be equal to infinity. So change the there is no change of limits, so your limits will be 0 to infinity, and what you have to replace, you have to replace that x by this one, that is y divided by log of m minus 1 raised to the power that m minus 1, and here we will suppose that that is equal to e raised to the power y, and dx is equal to what? Dx is equal to dy divided by log of m minus 1. So if you simplify that, the power, if you take power separately on y and log of m minus 1, and that will be goes toward the denominator. So here we have the function like this. So log of m minus 1 are the same with the power m minus 1 and 1. So if bases are same, so you can easily add the power. So from here m plus 1 and m minus 1 will be cancelled, so we will only have a m power. So your our integration is integration 0 to infinity y raised to the power m minus 1 divided by e raised to the power y log of m minus y raised to the power m dy. Okay, so log of m minus m minus 1 to the power m is the constant value, so take outside the integration, so our integration becomes 0 to infinity e raised to the power minus y raised to the power m minus 1 dy. So now again, if you compare that integration with the definition of a gamma function, so you can easily look over here that the both integration are same, so you can easily replace that integration with the help of a gamma function like gamma of n. So this is the solution of this question. Okay, a very simple solution, you can easily solve that question. Next question is show that integration 0 to infinity e raised to the power minus x squared dx, which is equal to 1 by 2 under root pi. Okay, so how to solve that question? Again, this question is solved by a gamma function, as you have a hint that integrate the limit of integration is 0 to pi, 0 to infinity, and a function is in a form of an exponential. An exponential function is like this. So first we will take that the left hand side of integration is equal to I. So now we will take the substitution in gamma function, e raised to the power minus y. We have e raised to the power minus y, but here in question we have e raised to the power minus x square. So we will take that. Let us suppose that that x square is equal to another variable that is equal to y. And if you want to change the power of that x, so that will becomes what? That will become x is equal to y raised to the power 1 by 2. So if you want to differentiate that, so you can easily differentiate as well that dy is equal to 2x dx. Okay, and if limit is x is equal to 0, so y is equal to 0, and if x is equal to infinity, y is equal to infinity, you can easily see from here. So there is no change of limit, so from number 1. Your equation number 1 becomes gamma m, same as it is. Limits are the same, 0 to infinity, e raised to the power minus x square, because here we will take that y is equal to x square. So replace that y by x square, y by x square raised to the power m minus 1, and dy is equal to what? 2x dx. So your integration becomes like this. Take 2 common here, and your integration is 0 to infinity e to the power minus x square, x is to the power 2m minus 2, and here we have x. So if bases are same, power will be added, so minus 2 plus 1 will be equal to minus 1. So your integration is like this. Okay, so 2 into integration of 0 to infinity e to the power minus x square, x is to the power 2m minus 1 dx. Okay, so if we will take now here we have to solve what? We have to solve that this one, e to the power minus x square. Okay, so if here we have e to the power minus x square, so what we have to do, we have to take the value of m like this, that if we put the value of m, so that the value of x will becomes 1. So for that we will take m is equal to 1 by 2. Okay, so if you change m by 1 by 2 in on the right hand side as well as on the left hand side, so on right hand side here we will write that that will be m by 2. If you put that 2 that will be cancelled. So here the left values are 1 minus 1, so 1 minus 1 is equal to 0, and x is to the power 0, as you know that any number with power 0 is equal to 1. So the integration becomes what? 2 integral 0 to infinity e raised to the power minus x square dx. And you then what you will do what? As you know the results of gamma 1 by 2, as we already studied, that that will be equal to under root pi. Okay, so that is equal to under root pi. So put over here, that will be equal to 2 integration 0 to infinity e raised to the power minus x square dx. Now replace that 2 towards the left hand side. So your integration, that is your desired answer, that integral 0 to infinity e raised to the power minus x square dx is equal to what? That is equal to 1 by 2 under root pi. And we have to solve that result. So hence proved. Next is again a proof, that is proof that beta m plus 1 n divided by m is equal to beta m into n plus 1 divided by n is equal to beta m n divided by m plus n. So what we have to do, we have to take this one left hand side and prove that that will be equal to this one result, and then we'll take that relation, and with the help of that relation we will find the right hand side relation. So this question is related to the beta function, so we will take a relationship between a beta function and a gamma function, and that will be beta mn is equal to gamma n divided by gamma m plus n. So what we have to find, the result of the left hand side. So here we have m plus 1, and in question we have m, so we will replace that m by m plus 1 in equation number 1. So put here m plus 1, and also divide that equation number 1 by m, 1 by m, that is put m is equal to m plus 1 and divide m on both side of 1, because we want to find the value of this one, this left hand side. So here we have m is equal to m plus 1 and also a value in a denominator, that is m, so that's why we will divide m on both side of equation number 1. So that will that from that we will get that beta m plus 1 n divided by m is equal to 1 by m into gamma m plus 1 gamma n divided by gamma m plus 1 plus n. Okay, so from here we have m plus 1, this is gamma m plus 1 gamma n. You can write this gamma m plus 1 plus n like gamma m plus n plus 1. Okay, and then you know the relationship of that gamma m plus 1 is equal to m gamma m. We can we also did that result, that how to find that result. So with the help of that result, you replace that gamma m plus 1 by m gamma m, and again apply also over here, that is m plus 1 gamma m plus n. Cancel this m and m, so the remaining terms are gamma n divided by m plus n into gamma m plus 1. take the common 1 by m plus n. So this the remaining terms, as you can see in equation number 1, that is a definition of what? That is a definition of a beta function. So replace that gamma n divided by gamma m plus 1 by beta m n. So this is the desired result, that we will take the left hand side and hence prove that right hand side. Now we will take that result, that we have to replace n by m plus 1 and divided it by 1 by n, or multiplied by 1 by n and divide by n on both sides of equation number 1. So equation number 1 now becomes beta m into n plus 1 divided by n, and 1 by n into gamma n plus 1 divided by gamma m plus n plus 1. Again apply this one result, this one, that gamma m plus 1 is equal to m gamma n over here, and also over here. So that will be n gamma n divided by m plus n gamma n plus n. Cancel the n terms. So the remaining terms are 1 by m plus n into gamma n divided by gamma m plus n. So you know this is a definition of a beta function. So replace that by a definition of a beta function. So that that is also equal to beta m n divided by m plus n. So hence prove that if we take this one relation, so that relation is also equal to that relation. So hence proof that this one from 2, that is from 2 and 3, the right hand side of 2 and 3 are equal. You can see the right hand side of 2 and 3 are equal. So it means that left hand side are also equal to each other. So from this results you can say by 2 and 3 beta m plus 1 n divided by m is equal to beta n m plus 1 divided by n is equal to beta m n divided by m plus n. Okay. And the last result is that proof that beta mn is equal to beta mn plus 1 plus beta m plus 1n. Okay, so we have to prove that relation. So you can see that if we take the left hand side, so it is it's very difficult to solve the right hand side, but if we take the right hand side, you can easily solve the left hand side, because in right hand side we have a lots of information as compared to right hand side. So and question is also related to the beta function. So here we are applying the definition of a beta function. And what is the definition of a beta function? With the relationship of a gamma function, and that is beta m n is equal to gamma n divided by gamma m plus n. Okay, so now what we will do, we will take the right hand side of equation number 1 and open these both beta function with the help of a gamma function definition. So your right hand side become gamma n plus 1 divided by gamma m plus 1 plus n plus gamma m plus 1 gamma n divided by gamma m plus n plus 1. So as you know that gamma m n plus 1 is equal to n gamma n, and gamma m plus 1 is equal to m gamma n, and also open that with the definition of this, or with the result of this, that m plus n gamma m plus n, and again open that m plus n gamma m plus n. Okay, so what we have to do, take the common terms from the both. So common terms are gamma n divided by gamma m plus n. The remaining terms are n divided by m plus n, and from here we have m divided by m plus n. Take the LCM of these two terms. So from here we will take n plus m divided by m plus n. We can also write as this m plus n, both are cancelled. So from here we will get 1, and from this is the, from here this is the definition of a beta function. So hence proof that if you take the addition of the relation of these two beta functions, so after addition of these two beta function we will get beta mn, hence proved. Okay, so hopefully you can understand today's lecture, because today's lecture are also very simple and also related to a relationship between gamma and beta function.